we are still on chapter 5, coordinate geometry in the xy plane. Today's discussion is how to identify whether lines are parallel and whether lines are perpendicular. Now, when you say lines are parallel, what do you mean by it? So geometrically, so to graph that one, lines are parallel. For example, let's say number 1, this is line 1, okay, and this is another line 2. So you observe that no matter how much we extend the line, they will never meet at all. So that means your line 1, if both of them will never meet, no matter how much we extend the lines, so line 1 is parallel to line 2. So this is the notation for parallel. Now, the second one, what is the geometric interpretation of perpendicular lines? So if this is your line 1, okay, and then you intersect a line 2 forming a right angle or 90 degrees. So two lines are perpendicular if they intersect at one point forming 90 degrees. So it means line 1, this is the notation, perpendicular to line 2. So parallel, they will never meet at all. Perpendicular, intersecting at one point forming 90 degrees. So this is the notation parallel, and this is for perpendicular. Parallel, perpendicular. Okay, now two lines, line 1 or line 2, are parallel. Parallel meaning they will never meet at all if, what do you mean by this? M1 is equals to M2 if their gradients are equal. If the gradient of line 1 is equal to the gradient of line 2, then they are parallel. Now, they are perpendicular. Two lines are perpendicular if you multiply their gradient, the result is -1. If you multiply, so M1 times M2, if the result is -1, then they are perpendicular. Okay, so for the next examples where we have pairs of equation of the line, then we'll just identify whether they are parallel lines, perpendicular lines, or neither parallel nor perpendicular lines. So let's start with this one. So we need to identify first their gradient. So let's start with number 1. So remember, if the line is of the form mx plus c, the coefficient of x will be your m. So in this case, for line 1, m1 is 4. For line 2, m2 is -1/4. So obviously they are not parallel, they are not same, so they are not parallel. So let's check, maybe they are perpendicular. So they are perpendicular if their product is -1. So let's check. So m1 times m2, m1 is 4 multiplied by -1/4 will give you -1. So since their product of the gradients is equivalent to -1, therefore two lines L1 and L2 are perpendicular. So they are perpendicular lines. So let's continue to example number 2. So here, again, coefficient of x, if it is of the form mx plus c, so m1 here is 5, m2 here is 1/5. So obviously they are not same, so not parallel. And then if you multiply this, we will not get negative 1. So therefore, the two lines are neither parallel nor perpendicular. So they are not parallel, they are not also perpendicular lines. Let's have the last example. Now here, we cannot directly identify the value of your m. So we have to change each into this form y equals mx plus c. So let's start with line 1. 4x minus 5y plus 1 is equals to 0. So all of this to be the other side. 4x minus 1, I want y, so I'll divide both sides by minus 5, minus 5, minus 5. So y is 4/5 x plus 1/5. So since we change the line into this form, the coefficient of your x is the m. So your m1 is 4/5. Now let's go to line 2. So line 2, 8x minus 10y minus 2 equals 0. Change it into this form. So minus 10y is equals to minus 8x plus 2. Other side. And then I want y, so divide all sides with minus 10. So y is 8/10x minus 2/10. Or remember, fraction should be in simplest form. So this will be, common is 2. 8/2 is 4. 10/2 is 5x. Also here, common is 2. And here, 5. So the coefficient of x here is m, which is 4/5. So m is 4/5. So we observe that both two lines, the gradients are same. Your m1 is 4/5, your m2 is also 4/5. So since they are same, since m1 is equals to the gradient m2, therefore they are parallel. So they are parallel lines. So two lines are parallel if the gradients are same. Two lines are perpendicular if this one perpendicular if the product of their gradient is -1. So that's it.